Okay, so here's the question you sent. And so what I'm going to do is I'm going to go to my notes and we can try to take an in-depth look at this. I'm going to go kind of back and forth, but first thing is about the leading coefficient. So we do have the leading coefficient test right here. It works great. If you want to just follow this, it's not really that big of a deal. So the way we'll look at this is look at the leading coefficient. Is it positive? No, it's not. It's negative. That's the leading coefficient, the one with the highest power. So that means that on the right end, as x goes to infinity, it's going to fall when you go to the right. So that's what's going to happen here. It's going to fall going to the right. Then the next thing is looking at the degree. If it's even, even Steven. If it's even, you're going to have the same behavior. It is even. Since it's a power of 4, it's even, so it's going to have the same behavior going to the left. And so that means that the left end behavior will be the same. And so that's how you do the leading coefficient test. And it's not bad to use, and this might be what you want to use. But I also sometimes like to kind of just take a deeper dive and kind of talk about why that is. And so the idea here is, I use the notation here, infinity, as x. You plug in a really large x value, and you could even do it yourself if you want to plug in a big number like 100, 200, 1,000, whatever, right? And when you plug it in, what's happening is you're having -1 times that value to the power of 4. And so when you plug it in, you get a really big number, but then it becomes negative. And remember, f of x is your y value, so that's what's coming back. And so yes, you have this 25x squared, but it's going to be very small compared to what you're going to get on the leading coefficient. And so if I plug in positive infinity, I get a big positive number, but then it turns negative because of the -1 in front. And so, that's why it's going to end up being this one right here. And so since, this one right here, so it's going to fall. And then if I were to plug in like a negative infinity, or, -5 billion, whatever you want to think of, a big negative number, well, since it's an even power, you're going to get the same result. And I kind of have that written right here. So whether you do 10 squared, that's the same thing as -10 squared, right? Or if you do 10 to the power of 4, that's the same thing as -10 to the power of 4. And so if your power is even, it doesn't make a difference whether the base is positive or negative. So if you plug in a big negative number, it comes back positive, but you've got that negative in front. Okay, so those are the end behaviors. And the way that works is that when all these higher order polynomials, they have some ups and downs and so on, but at some point it stops going up and down, and it either goes up or it goes down, something like that. That's just a generic drawing right there of whatever, right? And so that end behavior occurs at the most outer x-intercepts, left and right. And that's what we mean by left end behavior and right end behavior. So the left end, the farthest x-intercept, right end, the farthest intercept to the right. And so let's go ahead and look at our example we have here. And so let's see. So on our end behavior, we figured out that, right, they should both be falling. It's falling because it's negative, and the left end is the same because even Steven might help you remember that when it's even, it's the same. Okay. All right, let's see. So intercepts, and you said in your email that you kind of have the intercepts down, but we'll go ahead and just break everything down. So to find x-intercepts, you're going to set it equal to 0. See, you let y equal 0, or f of x in this case. So we have -x to the 4th plus 25x squared. And so I would factor out a -x squared is what I would do. And that would give us positive x squared minus 25. So it causes that sign change, and we're pulling out that x squared right there. And I can factor a little bit further right there because I have the difference of two squares. So x plus 5 and then x minus 5. So my solutions are 0 -5, and +5. And so the 0 comes from the x squared. Because if you plug in 0, that would go to 0, 0 times 0, and then it doesn't matter what the other ones are because you're multiplying by 0, and so everything zeroes out. Here's where the -5 comes from, and here's where the +5 comes from. And so when you're doing your homework, the next thing that's going to ask you is, where do they cross? And so they cross if the power of the factor is odd. So we're going to cross at -5 and +5. That's where we're going to cross. Okay. And then where we turn around will be at even powers. And so that's going to be at the 0 right there. That's where we're going to turn around. Okay. And I'm going to go ahead and pull up the homework so we can see that. Here we go. So let's see. First, we list our x-intercepts. So let's see, 0, and it doesn't matter what order you put them in, -5, positive. Oops. 0, -5, +5, any order. And then next it's going to ask, okay, which zeros cross? Well, that was -5, +5. And then next it asks which one turns around, 0. And then the y-intercept is pretty simple because you just plug in 0 for x, and that makes both terms go to 0. So that's pretty simple. It's just going to be 0. And then the last, we got to look at even odd. This one actually is an even function, and I will show you real quick on here. So it's algebraically it's even because all the powers are even. So whenever all the powers are even, it's an even function. If they're all odd, that doesn't necessarily mean it's an odd function, so be careful. But if they're all even, it's an even function. And what's going on here is whether you plug in like f of 3, that would be the same as if you plug in f of -3. Because when you plug it in, the even powers are going to cause your result to be positive no matter what, right? Prior to applying anything else that's going on, right? So whether you do 3 to the power 4 or -3 to the power 4, it's the same thing with the square. So this qualifies as an even function. And then the last part is graphing it. And so here, let's see, I thought I can enlarge it. So it's going to end up being D. And what I'm going to do here, I'm going to take a snapshot and we can look at it over here. Oops. Okay. So, all right. So you can see our intercepts here are at -5, +5, and then that's where it turns around at 0 right there. And you can see our end behavior, it falls to the left and to the right. So once you go through your last x-intercept to the left and your last x-intercept to the right, both of them, the direction is falling instead of rising, right? And so there's your intercepts. And then typically, I mean, things are a little different with everything kind of having to be computerized, but typically I'd have students do this on paper, right? And so typically you would test some points in between your x-intercepts. And so that might be some good practice to do that later. You know, try f of 3 and f of -3 was a good example. And you'll get the same result for those because it's an even function. And so that's one of the things that's helpful when you know that you're dealing with an even function, is that you know that you have that property right there, that whether I plug in -3 or +3, I get the same y value in return. So, okay, well, I hope that helps, and feel free to send me another one. I'm more than happy to send you back a video.